a substance, usually a solid chemical element or compound that can conduct electric under some condition, making it a good medium for control of electrical current. The properties of semiconductor depend on the dopant or impurities added to it. Doping is the process which impurities are introduced into the pure silicon, thereby changing its electrical properties and turn it into a semiconductor. Semiconductor can be made out of a variety of material, but the majority are made of silicon. Like carbon, silicon can make a diamond-like crystal. This structure is called a silicon lattice. Silicon has the properties needed to make a semiconductor. Okay, for silica is the one stable oxide of silicon. Silica also known as silicon oxide because its empirical formula is SiO2. Silica is not a silicon atom with the two double bond, two with oxygen atom. Silica is the composed of one silicon atom with the four single bonds to four oxygen molecules. Silica takes on this molecular form because silicon 3p orbitals make it more genetically favorable to create a four single bond with each oxygen rather than make two double bond with each oxygen atom. This leads to the silicon linking together in silicon oxide network, call it silicon.
Silicon does not exist as a free element in its natural state. It exists in the form of compounds such as silica and silicates. The appearance of a pure silicon is as shown in the picture. Silicon is a hard, dark gray solid with a metallic luster. Mobility can be defined as how quickly an electron can move through a metal or semiconductor. When it is pulled by an electric field, the term carrier mobility refers to both electron and hole mobility in semiconductors. In this picture, there are free electrons inside the semiconductor. It consists of large number of free electrons inside the semiconductor. When there is no field across the semiconductor, random motion of the free electrons takes place. Here we see the electrons move randomly, collide with each other. Now, under the influence of an electric field, free electrons start moving in a particular direction. Therefore, the net kinetic energy of the electron becomes constant. So, electrons move with a finite steady velocity, which is called drift velocity. As value of E1 is increased to E2, drift velocity also increases. Therefore, we have V is directly proportional to E.
Silicon is a group 14 element with relative atomic mass of 28.085 grams. Its electronic configuration is 1s2, 2s2, 2p6, 3s2, and 3p2. We know that silicon is a semiconductor, but with doping, we can have N-type semiconductor and P-type semiconductor of silicon. So now we see how to get N-type semiconductor. With doping with pentavalent atoms, for example phosphorus, silicon will remain electrically neutral, but an electron becomes available for phosphorus atom for free movement. The presence of free electrons makes the adulterated silicon quite a good conductor. This is how the silicon doping, this is the picture. And for the p-type semiconductor, silicon doping with trivalent atoms, for example boron, It remains electrically neutral, but a vacancy for electron becomes available per boron atom. The vacancy is named as hole in prevalent literature. Presence of electrons seeking holes makes the adulterated silicon quite a good conductor. And this is the p-type silicon, which is a reaction with boron.
So now I am going to continue talk about the properties of the silicon. As we all know, every element has the physical properties and the chemical properties. So the first physical properties of the silicon is that the silicon density is relatively small. It's around 2.3 to 3 GCM. And since silicon is a giant covalent structure, it's similar to diamond, in which each silicon atom is covalently bonded to 4 other silicon atoms in a tetragonal shaped arrangements, and that's why silicon has very high melting point and boiling point because of the held by strong covalent bond here. And this is why silicon is hard and brittle because of the giant covalent bonding. And move on to the chemical properties of the silicon. And the silicon is relatively inert, and it is very inactive element at room temperature. However, at high temperature, silicon becomes much more reactive. In molten state, it combines with oxygen, sulfur, phosphorus, and nitrogen, and with other elements too. It also can form a numbers of alloy very easily in molten state.
So basically, silicon is a covalent crystal structure where the atoms of the silicon atoms link together by covalent bonding rather than electrostatic forces nor delocalized valence electron. Silicon is actually an FCC crystal structure, but it is more to diamond crystal structure, which is more complex compared to the simple FCC crystal structure. Diamond crystal structure is also known as zinc blende crystal structure, where the zinc ion and silicon ion is occupied by carbon atom. This makes the silicon to be very resistant to deformation and extremely hard like diamond.
Okay, for my part, I will talk about the silicon application for industry. First, it is power plant. The silicon is used for the company in Japan likely to make a silicon solar panel. It will absorb energy from the sun and transform it to the electrical energy. Second is jewelry. The silicon is used nowadays to make a fake jewelry because this is much more cheaper than the original, and it can be shiny and beautiful. Next is silicon is also used for electrical components such as resistor, capacitor, transistor, diodes, and IC component. Then silicon also is used in automobile sector because the rim for car use the silicon carbide to make a rim car. Next is silicon also is used to make a drilling and grinding machinery. The silicon will induce with another component to make a cutting tools like the grinding machine, EMP machine, Swiss turn isohedral machine, and etc. Lastly, silicon also is used for photonic application. Photonic application is a technology like a data center, aerospace, and high-end technology, quantum computing, sensor and biosensor, and lastly is high performance computing. Thank you.